this example, we are graphing a quadratic function with a transformation. You've already done this a few times. I'm going to introduce a very short, quick method of doing this. You may have already seen it in a previous video, but it's called the mapping rule. I like to think of it as. So basically, the general rule is this. I take any points, I'll use x and y for my generic points of my base graph, and I map it to, so whatever the b value is, I'm going to use the reciprocal of it, 1 over b, x, and then minus h, which is the horizontal shift, and I'm going to have a y, which is the vertical stretch or compression, plus k, which is the vertical shift. So in this case, we have an h value, which is this guy over here. We have a k value and we have an a value. What we do not have is a b value. So fortunately for us, this drops out, or I mean, it's just 1. You're not multiplying the x value by anything here. So let's create our specific mapping diagram or mapping function here to get the points of x and y. So what do we have here? Well, that I'll just leave it like that. The h, however, I can replace with a plus 3, and the a I can replace with a negative 1 over 2, and the k I can replace with a negative 5. And right now, if I bring everything together, I'm going to bring this in, just make it nice. I have my mapping transformation. So what do I apply this to? What are the points x and y? Well, that's pretty straightforward, because you just take the base points of the function f of x equals x squared. And you should probably know these by heart now. Negative 2 goes to 4, negative 1 goes to 1, 0 goes to 0, 1 goes to 1, 2 goes to 4. You know what, let's just stick to maybe, no, that's fine, let's do the whole thing. So what's going to happen? Where are these points going to go? That's the original. Again, rough sketch, something like that, right? Where is this going to map to? Now, before, when we just did the rigid transformations, your shape was shifted left, right, up or down to some other spot. But now we're going to be reflecting this, and we're going to be compressing it vertically, so that the shape will change. So let's begin with this point, negative 2 and 4. So what does that look like? So negative 2 comma 4 is our starting point. That becomes negative 2 plus 3. Again, I'm putting x where x is, so negative 2, I'm putting negative 2 there. And then I have 4 for y, so that'll give me negative 1 over 2 times 4 minus 5. And if I do the math here, this simplifies to positive 1 and negative 7, because 4 divided by 2 is 2, minus 5 is negative 7. So that's our first point. What about our second point? We have negative 1, 1. That's going to go to, let's do this in our head now. That'll go to 2 and negative 5.5. Then we have 0 comma 0. That's pretty easy. It's going to move the vertex, 3, negative 5. And then we have 1 comma 1. That's going to go to the point 4. And what do we have here? Oh, I think I made a mistake. That is going to be 4.5, because that's a negative. And here it's going to be negative 5.5. Oh, no, never mind. I was right. For 1, it's going to be negative 5.5. It'll be the same. Yep, that makes sense. Then for 2 and 4, same thing. I'm going to get 5 comma negative 7. And you can see already maybe the symmetry here. The first these two here kind of match up. And if you recall, this point and this point, right? I mean, they're like opposite sides of the graph. You got one here, you got one here. So of course they're going to have the same, y value. Same with these two over here. Of course they're going to have, the same y value across there. Anyway, so again, if you look here, the negative 5.5, the negative 5.5. So our graph, again, we can just use these points. I'm going to do a rough grid. Our vertex is going to be at 3, negative 5. So let me move this x-axis up here a little bit and extend this. So there's my y, there's my x. So 1, 2, 3, and negative 5. So negative 1, 2, 3, 4, 5. I'm just, putting the vertex in. So 3, negative 5 is going to be right over there. 1 point, let's go to the right of it will be 4 and negative 5.5, so roughly over here. And then I'm going to go one more point over, which is going to be 5 and negative 7, which will be roughly, again, I'm just eyeballing this over here. Now everything on the other side, because this is the vertex, is going to be symmetrical. You can read off the points that we calculated, or just kind of, eyeball it. And let me zoom in here. If I connect it with a smoothish line, I get my parabola that's being shifted and reflected and compressed, all over the place here. But from the original, we get to this. If you want to see a clearer rendition of it, pull out Desmos, or if you want to go old school, get some pencil and graphing paper.